Right then, transformations. Starting off with D grade, so it's module 5, off the AQA syllabus. Right, transformations come in 4 main types. You've got translations, enlargements, rotations and reflections. Right, we're not going to deal with rotation or reflection at D grade, and that goes up to C and B grade. So starting off, you've got translation. Now translation is translating a shape. Now essentially that just means moving it, something across and something up or down. So something left or right and something up or down. Okay, the way that we use mathematical language to represent that is you get this vertical bracket, if you like. Really important, it's not a fraction, okay, it's just a vertical bracket. Now when you've got a sideways bracket, I'll use it sideways bracket, if I put 3, 2 into that, and that means 3 across and 2 up, so that's a coordinate, that's an actual point. If it's sorry, that's your horizontal bracket. Your vertical bracket, this describes movement, so this means 3 to the right and 2 up. Okay, basically your top number is your movement. If you think about your vertical bracket being over here, your top number here is your movement across. If it's positive it goes right, if it's negative it goes left, and your bottom number is your movement vertically. Positive if it goes up and negative if it has to go down. So right, I've written this one in blue, so I'm going to translate this square by 3, 2, which means 3 across and 2 up. So I'm going to take a point on the square, bottom right hand point, okay? I'm going to remember that's the bottom right hand point as well. I'm going to move it 3 across, 1, 2, 3, and 2 up, 1, 2. Now that point there is the bottom right hand corner of my square. It's a simple shape, so I can now just draw the shape in. Okay, and therefore that has now been translated. Okay, on the second one, the green one, just to highlight the fact that if it's negative it goes in the opposite direction. Again, my top number is movement left or right. It's negative, so it's going to go left. So this is going to be 4 back. So if I start with the bottom left hand corner this time, I don't have to, I could have used the same corner. I go, 4 to the left, 1, 2, 3. Ooh, this wasn't fantastically planned, was it? Here we go. That's better. Right, you go 1, 2, 3, 4, and then -1 means not 1 up, it means 1 down, so 1 down. Now there, that's my bottom left hand corner. So I'll draw the rest of my shape in, colour it in, and then this one is that translation there. So that's translation. If you want to pause the video now and attempt to translate the black square, let's say, let's try and translate it by that, sorry. So pause it now. Okay, presumably you've already paused it, so I'll put the answer in now. It means 3 to the right, 1, 2, 3, and 3 down, because it's -3, 1, 2, 3, that's my bottom right hand corner. And that's what you should have got. Right then, the second thing we were doing with this, guys, 3 minutes already, is we are going to do enlargement. Right, it's not perfect on this camera, so bear with me, my grids aren't fantastic. Right, enlargement. If you want to enlarge by a scale factor 1 is the same size. Basically you times every side by your scale factor and it gives you your new size. So if you use scale factor 1, I'd essentially get another t, which would be exactly the same size as the first t. Okay, it's a terrible drawing of it, but you get the idea. Okay, here I'm going to use a scale factor 2, so scale factor 2, so that means I double every side, 2 times every size. So my new t is going to be 6 across, it's going to be 4 down on either side, it's going to be 4 back in, okay, then it's going to be 8 down. You see how every single time I'm pointing at the side that I'm going to increase by that scale factor, and then if I've done this right I can check at the end, if it's on a grid for say, I should have 4 squares across here. Okay, and then this scale factor there has been enlarged by a scale factor of 2. Okay, imagine I had a scale factor of 3, then imagine I've drawn a bigger t, then my top number here, well, you think about it, scale factor of 3, 6 would become 18, we'd have 6 on the side because it's 2 times 3, got 6 underneath, 12 down here, and 2 down there. Okay, so what if it's on a grid? Right, I want to enlarge that shape, sort of a scalene triangle, by a scale factor of, let's make it scale factor 2. And I'm not sure if I've made my grid big enough to do it scale factor 3 yet. Right, scale factor 2, what you're going to do is you want every side to be 2 longer than it is, but you've only got, say, 1 vertical or horizontal side. Every other side you'd have to measure with a ruler. If they say about a point, then what you do is you take your point and you put your ruler on it. Okay, you measure the distance between that point and the vertex there, and then you double the distance because it's scale factor 2. If you do that, on a grid it's easy to see. Going from that point to your vertex, you go 1 down and 3 across. So to get a scale factor of 2, you want to go twice that distance. So instead of 1 down and 3 across, you go 2 down and 6 across. Okay, I'm going to use the same principle for the second one. 2 down, 1 across, and another 2 down and 1 across is going to be where that one goes. Then for the third one, you've got 3 down and 1 across, so that becomes 6 down and 2 across. And these 3 points then should produce a shape which is twice as big as the first one. Okay, scale factor of 2, so it's twice the size. Okay, I haven't drawn the grid big enough to do scale factor 3, but if you wanted scale factor 3, then what you'd do is instead of going 1 down and 3 across to plot that point, you'd go 3 down and 9 across. So 3, 6, 7, 8, 9 would be over there somewhere. Okay, the second one would go, instead of 2 down and 1 across, you'd go 6 down. So that's 6 down and 3 across, which would be that point there. And then the last one, instead of going 3 down and 1 across, you go 9 down and 3 across, which would be there. And then, well, I suppose, although the grid's not big enough, you can kind of get the idea. Okay, again, if you've got a ruler, then you can just measure the points, but if you're on a grid, it makes sense to use those squares, okay, because that's what the examiner will be looking for. Right, I hope that was useful. Sorry it was so long.